All right, guys, today we're going to evaluate and graph polynomial functions. Quite a bit of stuff in this one today, so hang in there. Get ready to take some good notes. First of all, polynomial functions. This is the 4 or 5 biggest types, but obviously there's more than this. First kind is when you have degree 0, which means there's no x in your equation. It's just like y equals some number like 3, like this right here. F of x is negative 14. We call that a constant. Because it equals the same thing all the time. That's very constant. Linear has degree 1. It has an x with the 1 as an exponent. It would look like slope-intercept form a lot of times, like this right here. F of x is 5x minus 7. The third one is quadratic. That means it has an x squared. The form for x squared is usually ax squared plus bx plus c. We've done that lately. Looks like that. Cubic is what you would think. Degree 3. Biggest exponent is 3. Quartic. Biggest exponent is 4, that's degree is 4. So those are standard forms where you have f of x equals the function, and depending on what your highest exponent or your degree is, that's what we name it. First kind of problem, decide whether the function is a polynomial function. If so, write it in standard form. Say its degree, its type, and leading coefficient, which is going to be very important as we move on. First one, part A, is a polynomial one. It's already written in the right form. It's quartic, so we're going to name it. Let's see, does it say to name it? Yeah, it says type, so we get to quartic. Its degree is 4. Leading coefficient is 1. Leading coefficient is the coefficient in front of the biggest exponent, or what the degree is. Part B, if we're going to rewrite that one, we always want to write the degree term first. I'm going to put pi x squared plus 7x minus the square root of 3. It has degree 2. It is quadratic. And the leading coefficient, I'm looking at the coefficient in front of the degree term. It would be pi. Let's get these last two here. Part C. Part C is not a polynomial function because it has a negative exponent on a variable. One rule about polynomial functions is you cannot have variables in your denominator, and technically that term right there is 3 over x, so that is not 1. And then part D, the last one here, you'd rewrite it like this. You'd say k of x is negative 0.6 x to the 5th plus x. Actually, I just saw this. You cannot have x as an exponent either, so that means that is not a polynomial. Did not notice that until I just wrote it all the way out. So that would be not a polynomial function. All the exponents must be whole numbers for it to be a polynomial function. All right, so use direct substitution to evaluate 2x to the 4th minus 5x cubed minus 4x plus 8 when x is 3. So all you do right there is you work out f of 3. So when you work out f of 3, all you do is you plug 3 in everywhere you see an x, and we're going to work that all the way out. So it's going to look like this. Yeah, and now it's going to work that out. 3 to the 4th power is 81. 5 cubed is 27. Sorry, 3 cubed is 27. 4 times 3 is 12 plus 8. Keep going there. That's 162. 135 minus 12 plus 8. Now I want to do all that math at the end. I'm going to get 23. So all you do when it says use direct substitution is you plug a 3 in or whatever term they give you there for all your x's and work it out. Okay, another way to do it is called synthetic substitution. This is going to be new. It's really good. Watch what I do here. I'm going to call this a box. I'm going to put a little box right there. It's really a backwards L. And whatever they say to evaluate the substitute, I'm going to put that number inside my box, the negative 2. Out beside the box, I'm going to list all my coefficients, 1, 2, 3. And if you're missing a term, like I'm missing an x to the first term, I'm going to put a 0 in its place, and then put the negative 7. Skip a line, draw a line. And the process works like this. I'm going to bring the first number all the way down below the line. Every time I bring a number below the line, you multiply by what's in your box. 1 times negative 2 is negative 2. You write that underneath the next number, add, you get 0. There's my next number below the line. You do 0 times what's in the box, negative 2. That's still 0. Add them up. I got another number below the line. Multiply by what's in the box. That's negative 6. Add them up. Multiply by what's in the box, by what you brought down. That'd be positive 12. Add them up. 5. That's known as your remainder right there. And what the remainder is what you would get if you did put negative 2 in. So my answer is just f of negative 2. If you were to plug it in, you would get 5. Works, gives you the same answer as direct substitution, a little bit quicker, a little bit easier, and once you do a few of those, I think you're going to like that even better. All right, this is a very important slide, and we're going to do some gestures on this tomorrow for sure to help you get it, but basically there's some patterns that they want you to see, and that is this. When you have an odd degree, when your degree is odd, the ends of your graph, the ends are going to go in opposite directions. This one's degree odd also. Look at the other degree odd. The ends go opposite directions. It's called end behavior. What are the ends of your graph doing? And when their degree is odd, they're going to go opposite directions. Now, when it's positive, it's going to go down to the left, up to the right. When it's negative, it's going to go up to the left, down to the right, just the opposite. And the way we're going to write it is this kind of form. And I will tell you more about that tomorrow. Basically, what this says is, remember, f of x is y. It's saying y goes to positive infinity, which means y is going up as x goes to positive infinity, as x is going to the right. So it's basically saying as x goes to the right, the y is going up. As x is going left, the y is going down. Same thing over here. As x is going left, the y is going up. As x is going right, the y is going down. That's what those say. That's what those mean. We'll work on that. I know it's a little bit confusing. We'll work on that tomorrow for sure. It's not really as bad as it sounds. Okay, when you have even degrees, both of these are even, instead of the ends doing opposite things, both ends go up or both ends go down. The ends of your graph do the same thing if they're even. If it's positive, they both go up like you'd probably expect. If it's negative, they both go down as you'd probably expect. These sentences are the same. As x is going to the right, y is going up. As x goes to the left, y is going up. As x goes to the right, y is going down. As x goes to the left, y is going down. That's what those are saying. All right, no big deal. One more slide. All right, they're going to give you one to graph. I want you to graph these. Now, when we graph them, what I'm looking for first is what is my degree and what is my leading coefficient. My degree is odd, and my coefficient is, leading coefficient is negative, which means already I know this. I know this end is going to go up, and this end over here is going to go down. You know, I know that for sure just based on the last slide. So I got to fill in kind of what's in between. I also know that my y-intercept is always my last term right there if it's in standard form, because if you plug in zeros for all your x's, it gives you -3, so I know my y-intercept is right there. So what I'm going to try to do is find my x-intercepts and just kind of estimate the rest of the graph. So I'm going to factor this thing, and when you factor 4 terms, the only way to do that is to factor by grouping. So I'm going to take a negative x squared out of the first 2 terms. That would leave me an x minus 1. I'm going to take a 3 out of the second 2 terms, which would also leave me an x minus 1. So if I take out the x minus 1, it leaves me a negative x squared plus 3, which means one of my y-intercepts is, one of my x-intercepts is 1, because it makes it 0, so there's one of them. My other 2 are going to come out of here, and they're both going to be square root of 3, because I need to make that 3, that parentheses become 0, and if you square the square root of 3, it gives you 3, and -3 plus 3 is 0. And we'll work on that. I know there's a lot to say right there. Square root of 3 is like 1.7 something, so it's about, I'm going to say it's about right there, and also -1.7 something. So my graph's going to do something like this. I probably need to erase my end points there. It's not going to go quite that far out, I don't think. And we kind of estimate my graph to do something like, remember we talked about it's going up there, it's coming down, it's going to go back up and across here and then back down just like that. So that's, and all I'm asking for tomorrow is really a kind of a rough sketch of your graph. We're not going to make an exact graph. It's really almost impossible to do unless you use a calculator. So, but it should look, you know, that way. You should have your x-intercepts, your y-intercepts, and it should be, your ends should be going the right direction. So that's the main thing. That's quite a bit of stuff. Hopefully it wasn't really bad though, and we'll work on it like we always do tomorrow, and look forward to seeing you. See you, bye.